Hello everyone, this is Mar Haddad here again. In this lecture, I'm going to explain to you about VLAN. So what is VLAN, how does it work, what we need to do in order to configure VLAN in our network, and of course we are going to see what is the benefit of using VLAN in our network. So this is what I'm going to do in this lecture. I'm not going to do the lab now. The lab will come after this lecture directly. So now let's go and check what is VLAN and why we need to have VLAN in our network. Okay, to make it easy for you, I just make a drawing here to explain to you how we can apply VLAN inside a company. For example, let's say we have this company here, and this company consists of 3 floors. Floor number 1, first floor, second floor, and third floor. In the first floor, there are 3 computers connected to this switch. On the second floor, there are also 3 computers connected to the second switch, and on the third floor as well, 3 computers to the switch, and then all switches are connected to each other via one switch. So in this case, we have one network where the 3 floors are connected to each other. Okay, so if we don't use VLAN, this is what we normally call a flat network. Flat network means that we have only one network, which is like you see here. This is the whole network that we have. Okay, and on this network, all computers are able to communicate to each other. Okay, so in this case, we only need to provide one network ID. So I'll put here network IDs. For example, we say here we will give to this network 192.168.0.0/24. That means this computer, for example, the first one here, he would take 192.168.0.1, this 192.168.0.2, this 3, 4, 5, and until .9 here. Okay, so you will see that all are on the same subnet, and that's something we will have problem with that, especially when we need to divide our network into different departments. Okay, we will see it in a moment. But the idea is that every computer will be on the same network. Then if we go back to the network basics, and we know that one computer, when he wants to communicate to another computer, he needs to have the IP and the MAC address of the destination computer. That means the computer that he needs to send to him his frame. So in this case, let's assume that computer 1 would like to speak to computer 9. So he will check, okay, I have the source and the destination. So the source MAC and the source IP, which is his own MAC address and his own IP, he has them because it's for him. But he will see that he's missing the MAC address of the destination, but he has the IP of the destination. So he knows the IP of the PC number 9, but he doesn't have his MAC address. In this case, he needs to do a ARP request. That's something we go back to the network basics, and ARP request is exactly when he would like to know the MAC address of the destination. And also from the network basics, we know that ARP is sent via, if you remember, broadcast. Okay, so there will be a broadcast. And broadcast is very bad for our network because in this case, our network will not be working anymore. It will not be functioning anymore. That's broadcast. So the ARP request is sent via broadcast. That means when computer 1 is sending the ARP request from here, it will come to this switch. And this switch will send it to all ports that he has, because it's a broadcast. You don't know where it's going. So we send it to all ports that he has active, and not only from the port that he received from it. So he received this ARP request on his port. He will not send it back because he received from that, but he will send it from here. He will send it from here. He will send it from here. So it goes to computer 2, computer 3, then it goes here. It will send to here and to this switch. The switch send it here, here, here. And also it will go to this switch, and this switch send it here, to here, to here. So you can see that because we are in a flat network, then the broadcast is sent to all computers and all our network, and this is causing problems to our network. So this is what we call in the flat network. We have a one broadcast domain. Okay, one broadcast domain. That means that the broadcast is sent to everyone in the network. So it's one domain. Okay, so you can see this is one broadcast domain. So the whole network here is a one broadcast domain. So this is one problem of the flat network that we can see now, that in case there is any broadcast and in the network, there are a lot of broadcasts. You can have ARP requests, you can have DHCP requests, you can have many other type of protocols that needs broadcast. And then in this case, every time there is a broadcast, the whole network will not be functioning anymore. And that's a big problem that we have in our case. And as you remember, because we are working on switches now, and that's layer 2. And layer 2 doesn't divide broadcast, it only divides the collision. So it can make different collision domains, and the switch can do that. But broadcast, you cannot stop it. It's only the router which can stop it. Okay, so that's one problem that we have. So we say here we have one network ID, and then 2, it's one broadcast domain. And that's another major problem that we have. Okay, now let's check also the third problem that we may have here. But let me first clean a bit the pictures to be able to explain to you the third problem. Now, the third problem that also we may have here is, in case, for example, we say, okay, for floor 1, I want all sales people to be connected to the floor 1. So this switch here is connecting all computers which are from the sales department. And we say on the floor number 2, I would like to have the finance. Okay, let me grab another color. So we say here, this is for the finance. And for the floor number 3, we say here we have the, for example, marketing. Okay, so what will happen now that, okay, we divided physically the users which are in each of the department to be connected to each other. For example, in our case, we say floor 1 is sales. That means all computers which are on the floor number 1, they are from the sales department. So they are all physically connected to this switch. Okay, and then the same for the finance and the same for the marketing. So here the problem is we cannot apply security to say, well, we don't want the finance department or finance users to get access to the sales users. Okay, so that means the PCs of the finance to be able to get connected to the PCs of the sales, because again, they are on the same network, they are in a flat network. So we cannot also apply a security policy here, because at the end they are on the same network, and that's also a big problem that we may encounter, that you cannot also make security. And that's also point number 3, which is that we have problem with security. Okay, so we cannot secure our network and say, well, this department, I would like also, for example, the sales, to not allow them to do that and that and that, and also allow them to do this and this and this. Same we do on the finance, on the marketing, because at the end, if we want to make a security, it's going to be for the whole network, because again, it's a flat network, it's one network, it's one subnet. Okay, so in this case, we have also problem with security. And the last thing that I want to explain here, this the problem. Let's imagine that we have on this number 3, we said it's on marketing. I will take the green color, and we say that this switch goes off. Okay, in this case, when the switch of the marketing goes off, then the whole network or the whole computers which are connected to this switch, which are the marketing users, they are also not able to work on the network anymore, because the switch is off. Okay, and that's also another problem. So we have a major problem that in case a switch is off, for example, it gets damaged or it's not working, or someone took the power out of it, then in this case the users which are sitting inside the marketing department in the 3rd floor, they're also not able to be connected to each other. So there will be each computer a standalone computer. And we know in our days we really need a lot to have access to the network to be able to make our work. Okay, same applies for the other switches, for the finance or for the sales. So that's also, we can say here, one point of failure. So if we go here to point number 4, we can say one point of failure. Okay, and in our case, the whole marketing department will shut down and we will not be able to work in case the switch is off. So these are the main ideas that we have in this case, and we can also add on it one more point. Like, for example, say that the switch of the marketing is working, okay, and we have the network is working, but we need to add one more employee. And on this switch of the marketing, employee working for marketing, then this switch doesn't have any ports left to be able to connect to the user to that switch. Then in this case, if we say that only on the third floor are the marketing and we don't have any switch anymore available to have a port to connect to it, then we will not be able to connect them, for example, to this switch or to this switch, because we have defined it that the switch of the floor number 2 is for the finance and the switch of floor number 1 is for the sales. So we only want to group them physically from the same department. And that's something also a problem that we can name it, because also in this case we need to buy a new switch and we need to have more ports to be able to connect the new marketing guy on the new switch, which normally should be connected also to the switch of the marketing. So these are problems that can happen when we are deploying a flat network. That means one network and all users are on the same network ID. They can cause a lot of problems of broadcast. There's no security that we can assure that each department is not able to see the other, for example, on the network, and then we have one point of failure. So these are the main problems that you can have when you deploy a flat network. So for this case, we need to have VLAN, and VLAN will solve for us all those problems that we just have explained now. So let me now show you, in case we have the same case and we apply VLAN, what will happen and how those problems that we have just mentioned now will be solved. So here is our same scenario. We still have here the headquarters, for example, or the building, and those are the 3 switches connected to the main switch, and they have the users connected to each of the switch. Okay, so instead of saying that floor number 1 is for sales, floor number 2 is finance, and floor number 3 is marketing, what we can do, we can create VLANs. And we can say, okay, VLAN number 10, let me write it on the blue color. So we say VLAN number 10 is for sales. And then VLAN number 20, it is for, we said here, finance. And we take the red one, VLAN number 30, it is for the marketing. So that's something, the VLAN, it's virtual local area network. So that's something virtually. So we still physically, if you see physically, the same computers are still connected physically as it was on the previous case. So if we go to the previous slide, we see that 1, 2, 3 PCs connected to this switch, 1, 2, 3 PCs to this switch, 1, 2, 3 PCs to this switch, right? But in this case also, we can look that 1, 2, 3 PCs connected to this switch and so forth. So all the physically switches are still connected as they are. But virtually we are creating VLAN, and then why we do that? To separate the departments from each other. So we can say, okay, I will create VLAN 10, and on VLAN 10, I will say that this is for sales. And I put the computers on the VLAN. So actually, it's not the computer that we can put, it's actually the port which is connected to the computer. So in our case, we say that VLAN 10 is this one, the blue one. So I will come to this switch, I will say this port, and this port, and this port, I would like to put them on VLAN 10. So when we put the port inside VLAN 10, then directly the PCs which are here connected to those ports, they become like they are connected to the same switch. Okay, so they will be like one network together. All right, so also I will do the same for the, if you can see here, we say, okay, for this port, which is connected to this PC here, and this port, and this port, I will make them inside VLAN 20, because VLAN 20 is for the finance. And then those computers which are here on the yellow circle over here, they will be inside VLAN 20, and I define that VLAN 20 is for finance. Then in this case, those PCs, they will be working together only. Okay, and same I do at the end for the VLAN 30, and I will say that this port and this port and this port, which are connected to those PCs here. Okay, so I will make those ports on VLAN 30, and I will say that VLAN 30 is for marketing. Then in this case, what will happen, that here all users will be in the marketing, and here all users will be in the finance, and here all users will be in the sales. Okay, so what does it mean? It means like we are grouping the same users or the same PCs based on the function they do, even if they are connected physically to the same switch, but they are not able to communicate to each other. So you can see here that this PC and this PC and this PC, they are all connected physically to each other. You can see here the cable, they are connected physically to each other, but they cannot communicate to each other. Why? Because each of the PCs are inside a different VLAN. And in this case, what will happen is we will solve the problems that we have just mentioned here, which are the network ID, the broadcast domain, the security, and one point of failure. How we can solve the problem? Let's first talk about, we said first, the network ID. So it's a concept that you have to remember. Each VLAN has a network ID. That means, in my case, I will say, okay, for sales, I will say the network ID will be 192.168.0.0/24. That means this will have 192.168.0.1, this .2, and this .3. 192.168.0. something. For the finance, I will say, okay, for the finance, I will take the range of IP of 10.10.10.0/24. Then in this case, the finance here will have 10.10.10. something. So here is .1, here .2, here .3. Okay, so you can see they are on different network ID. So I'll put here 192.168.0. something. Okay, and then at the end also the VLAN 30, which is the marketing, I will give an IP address to it. For example, 172.16.0.0/24. So here it will be 172.16.0. something. Okay, then here is 192.168.0.1, the 2.3. So that means that each VLAN will have its own network ID, and we solved the first problem that we have seen in the flat network. The second thing is the broadcast domain, that we've seen that it's a major problem on the flat network. In our case, when we are creating VLAN, what happened is that each VLAN or computers which are connected to VLAN, when I say computer, I'm saying host. It can be anything as a network device, okay? But in my case, I just have computers here. So the broadcast domain means that each VLAN will have its own broadcast domain. So for example, let's take the case of the VLAN sales here, okay? So what will happen in case, for example, we said the PC3 want to communicate to PC1 of the VLAN 10, which is the sales VLAN, okay? And he doesn't have the MAC address of the PC1. Then he will want to do an ARP request, like we've seen in the previous slide, okay? So the ARP is going to be broadcast. Then the broadcast, it will go from here to the switch. In this case, the switch knows that that's a VLAN, and he will not send it back to this PC here and to this PC. He will not do that. He only see where are the computers which are on VLAN 10, and he will send them. So we see that I don't have here any VLAN 10. So let me send it to the trunk. We will talk about the trunk in a moment. And he will send it to this switch. Then this switch will see, okay, this is a broadcast on VLAN 10. Then I will send it only to here. Also, it will go up to this switch, and this switch also will look and say, okay, this is a broadcast for VLAN 10. I will send it only to here. So he will send them only to, actually, to ports which are on VLAN 10. And in this case, it will send only to the computers which are inside the VLAN 10. So the broadcast is only affecting what is inside the same VLAN. In my case, the finance here, they have no problem. So they're still functioning. They don't receive any broadcast. And the marketing also, they're still functioning. They will not receive any broadcast. And this applies to each of the VLANs. Okay, so again, each VLAN creates a broadcast domain by itself. And when the broadcast is sent from a VLAN, it will not propagate to other VLANs. It will stay inside the same VLAN. Okay, so this second problem is solved. The third problem is security. In our case, as we already have different network IDs, okay, so you have to think they are like different networks. So each VLAN have a network ID different from the other. What you can do, we can apply security very easy. Okay, so the problem of the security also is solved because in this case you are applying security on the VLAN, and each VLAN is representing a department. So in our case we have the sales, the finance, the marketing. So in this way we don't have any problem to make security rules. Okay, so that's also a problem that is solved. And the last problem, we said here that in this case, there is a one point of failure. So, for example, if we say here that the switch of the second floor goes off, okay, so it's not functioning anymore. Before, in our case here, if we go back here, if the switch of floor number 2 is off, then all marketing will be not able to work anymore, because that's where we grouped all marketing users on the floor number 2. But in my case here, if I apply VLAN, if I go back here, if we say that the switch of floor number 2 goes off, then what will happen that this PC and this PC and this PC will not work anymore. That's correct, yeah, because they are physically connected to this switch. But it doesn't mean that the whole marketing department goes off. So for example, we can see that those two, they are able still to communicate to each other because they did not get affected. Also for the finance. So they are still able to communicate to each other, the finance. Also for the sales, those two PCs. So we don't have like a single point of failure, like if a switch goes off, then the whole department goes offline. Okay, that's not the case in what we have here. So because at the end, all switches are connected to the main switch, which is here. So this is the main switch here. So in this case, if this goes off, then those two are still functioning because they are connected to the switch. Okay, then also this problem is solved. And one more problem that we have talked about, we said, let me just clean it a little bit. So the other problem, we said that, okay, if this switch, for example, on floor number 3 is full, there is no more place or there's no more ports on the switch to add. And you have a new colleague coming to work on marketing. And I said, well, I want to put it on floor number 3. And then I looked on the switch, I saw that there are no ports left. So that's no problem. Then I will look to other switches. I will check, okay, on switch number or floor number 2, there is a port available here. So what I can do, I can, okay, make here a connectivity to this PC and for this employee. And then I put this port, because he's going to work on marketing, on VLAN number 30. When I put it on VLAN 30, then this computer will belong to this VLAN. Okay, so he will be one of the members of this VLAN, and he will be able to be on the same network where all those computers are, which are on VLAN 30. Okay, so that's much easier when you apply VLANs on your network, and it makes much easier for you to manage your network and to make your network more scalable. Okay, so I highly advise that you don't go to flat network unless you have a really, really small network, like 10 computers or something. That's possible. But when you have a big network with different departments, then VLAN is always the best solution. So now we understand the concept of the VLAN. I just want to explain now more technically about the VLAN. So what is the access port? What is the trunk port? How we want to create the VLAN? How we can assign the ports and say that this port on the switch need to be on this VLAN and so forth. So let me show you one more slide to explain to you about all technical details of VLAN. So now we know the idea of VLAN. I would like to now explain more about the technical details that is needed to be known in order to be able to configure the VLAN on your network. Okay, so the first thing to understand is that you have two types of ports that you can use on your switch when you want to configure VLAN. You have something we call access and something we call it a trunk. Access, that means what? For example, we came and said that this is VLAN, for example, 10, this is VLAN 20, and this is VLAN 30. That's what we want to do. Okay. So in this case, all PCs here, they should be on VLAN 10. So how to do that? When we say we are going to connect to end users, okay, then in this case we are talking about access. Okay, that means a switch connected to a computer, a switch connected to any network device that's gonna be as an end user. Okay, so in my case, that what I want to do, I will go to the ports where it's connected to this PC here. Okay, and before I go to the port, I of course need to create the VLAN. So first thing, I create VLAN. So VLAN creation. Okay, so I will say, okay, on my network I need VLAN 10, 20, and 30. So I create VLAN 10, VLAN 20, and VLAN 30. And this needs to be created on all switches that we are going to use. So that means on this switch, on this switch, on this switch, and on the main switch. So the VLAN needs to be everywhere. Of course, depending on what type of switches you are using, you can, for example, if you use Cisco, you can create the VLAN on this switch only, and then the first one you say, okay, here I want to create VLAN 10, 20, and 30, and then it will propagate the VLAN to all other switches. So you don't need to do the work on every switch. Okay, same if you use Huawei as well switches, this is possible. Okay, but it's now not the idea of how you do it, it's only to know the concept that those VLANs needs to be on every switch that are going to use this VLAN. Okay, so first we create the VLAN, and then second we assign VLAN to port. So we assign VLANs to ports. Okay, so in my case I will come and see, okay, on the switch number of the floor number 3, I will say this port, which is in my case, for example, Ethernet 2, okay, I want to put it on VLAN 10. Then this PC becomes inside VLAN 10. Then this port, I want to put it on VLAN 20. Then this port, I want to put it on VLAN 30 because the PC is needed to be on VLAN 30. So here what I'm doing, I have first to make the ports access, and then I assign each port to a VLAN. Same I do on this switch, and same I do on this second switch. Okay, then when we do that work, so for example, we also made this port access, and this port access, and this port access. Then I said, okay, this port is going to be VLAN 10, this is VLAN 20, this is 30. Then also I will make this access, and this access, and we put it on VLAN 10, 20, and 30. Then in this case, we have this scenario that we are seeing here in front of us, that all PCs which are on VLAN 10 that are able to communicate to each other, and all the PCs which are on VLAN 20 are able to communicate to each other, but 10 and 20, they are not able to communicate to each other because they are on different VLANs, okay? Unless you use a router at the end, and that's what we call it, router on a stick, but that's out of the scope of what I'm explaining now, okay? So then that's what we need to do. So again, first we create the VLAN, 2, we make the port access which are connected to the host, and then we assign to each port on which VLAN he should be in, okay? And now, because we are using 3 switches and the VLANs are spread into 3 switches, then in case we say that the computer which is sitting here, for example, this one, if you want to communicate to the computer on his same VLAN, which is here, then in this case, the traffic is going from the PC to this switch, and this switch needs to send it to here, and then here the switch will know that he wants to send it to this PC here. So that means we need to do something we call a trunk. So we just talked about the access, now we need to do the trunk. So the trunk is what? The trunk is between switches, like switches which are carrying the same VLAN, they need to have trunk between each other. And why do I need to have the trunk? So when you make trunk, for example, in my case, I will say, okay, this port, because it's connected to switches, is going to be a trunk. This port is going to be trunk. This port is going to be trunk. And of course, this port is going to be a trunk. Okay, so when we say trunk, then in this case, what happened is that inside the trunk link that I'm using on between the switch, the package of each of the VLAN will pass. Of course, you can say which VLAN you want to pass. By default, they will pass all the traffic of the VLAN. That means we will see that on this switch, he will send the traffic of VLAN 30. I'll make it red as it is for the VLAN. Okay, and it will pass also the traffic of VLAN 20. And he will pass also the traffic of VLAN 10. Okay, Same for the switch number 2, which is second floor, and for the switch number 3 of the third floor. Okay, so that means the trunk will carry all packets of all different VLANs to be able that this PC at the end here is able to reach this PC. That means that in case this PC wants to send also a frame to this PC, he will send it to this switch here, and this switch has a trunk. Then he is able, we take the yellow color, he is able to send via the trunk the packet to here, the frame to here, and it will receive to this switch, and then this switch, he knows that it needs to go to VLAN 20, then he sends it VLAN 20. Okay, it's only the trunk can carry different VLANs. The access will only carry the VLAN that you assigned inside it. So you say, okay, on this port is VLAN number 10, then it will only send to VLAN number 10. Okay, now this is the difference between access and the trunk, so I can repeat it. Access, when you are connected your switch to a host, and then on this switch you create the VLANs, of course, and then you say that this port is access, and you put this port inside the VLAN, like I explained. The trunk is when you have 2 switches, 3 switches connected or more, and they need to carry all the traffic of the VLAN, then you make it a trunk in order to carry all the traffic of the VLAN. Now, it's very important that when you make trunk, the protocol that is used is 802.1q, and that's the encapsulation. Okay, encapsulation that's used for the trunk, 802.1q. Normally it's called .1q most of the time. And Cisco used to have a protocol called ISL. That's also for trunk, but it's not used anymore. It's discontinuous. Even Cisco took them out from their operating system. Okay, so the standard for trunk that you can see in every switch is 802.1q. Okay, so that means that when you want to configure the trunk, you need to enable the protocol of the trunk, which is 802.1q. That's the encapsulation protocol. So that's in brief what I wanted to explain about the difference of having VLAN and not having VLAN. Of course, now you can say, well, okay, we understand VLAN, but how can we apply that to our scenario, which is distributing internet to customers? So how we can do the VLAN there? And that's something I'm going to show you directly in the upcoming video. I'm going to do a lab, and we will use the same scenario that we were using, but instead of having 2 interfaces going from the main router, we are going to have one interface, and then we create the VLAN, and we will see how it works. Of course, we're going to pass through the trunk and the access and the creation of the VLAN and everything. But it's very important at the beginning, before you start working with the VLAN, so you understand what is VLAN and why it's important to have VLAN and what is the benefit of using VLAN. And then when you have this concept in your mind, then it's quite easy to apply it on the lab. So this is what I wanted to show you in this lecture. I hope that now VLAN is more clear for you and you understand now more why we need to have VLAN. And let's now go directly and start with the lab of dividing the internet to customers using VLAN.